YouTube is setting everything up, so it should be a few seconds. Hey, hello everyone. Welcome to another session of Amplifying F Sharp. You might know us by now. We have been running this initiative for now more than 2 years, I believe. The last session we had was last year, so yeah, I wanted to wish everyone a happy new year. Hope you had a great break, Christmas break. And today, as is usual, we have a member of the F-Sharp community that want to show us some cool stuff that he have been building in the last couple of months, maybe. And yeah, but before we go to the session, I would like to really just do a little bit of housekeeping with Amplifying F Sharp. Amplifying F Sharp exists, or it's in place to try to bring people together, bring F Sharp developers together. And the way that we do that is by helping them contribute to the F Sharp ecosystem. It can be through like compiler contributions, tooling contributions, libraries in general, or even like today, a showcase of what you are doing and why are you doing this. So yeah, so if you have any idea or any you want to give a session with us, you can visit amplifysharp.io, and here there's a button that says join us. If you press join us, you will be shown a form where you need to give us your name, your company, the time zone that you are in, and the topic that you want to work on. And if it's an issue, it's a specific project, or if you still don't know what to do, but you want to still, you want to figure out together how to do or what to do, just, fill this form, press submit, and then we will get in contact with you to propose a session, a date as well. We will schedule a session, and that will be pretty much it. But yeah, without further ado, I'm going to introduce the session. So today we have Vladimir from the F-Sharp community, and he is the maintainer of an interesting library called Oxpecker. It is a revision version of Giraffe, I believe. Who does good new things, improve things, performance, has a different design decisions, and yeah, I've been pretty curious about this library. So yeah, I'm really happy that we have a session today. So yeah, I will hand it over to Vladimir, and we can start the session.
Okay, let me share the screen. Hello, everyone, and thanks for coming today. Today I'll be talking about Oxpecker and its performance in Tech and Power benchmark. The whole story started long time ago, and not just the Oxpecker's story. My whole F-sharp journey started from the competition called Pilot Cup, and it actually was not just one cup; there were two cups, but one of them was more important. The first one. And this is where I started doing F-sharp. At that time, I was just writing C# code. And when I knew about this highlight cup, and I also had a friend who was doing functional programming, I decided, why not try this and do it in another language? The highlight cup was quite interesting because that competition allowed you to compare any languages, any web servers, that could just run in Docker and serve HTTP requests. It measured pure web server in-memory performance with a gradual load increase up to 2K RPS. What you had to do is just to quickly respond to all those requests and not to miss anyone. And finally, the solution which gave the best summarized latency, it actually won. And at that time, I started with first ASP.NET Core, of course, but then I knew about Giraffe. Giraffe was starting that time. It was brand new. So I used that, and gave pretty decent results for me, although sometime later I had to fork it and rewrite a more effective way to get better performance. But still, it gave me a lot of experience of how to make things faster. And then next year was another round of this competition called Highload Cup 2, where things started being more complicated. So data size increased, more algorithmic requirements were added, more complex query cases. So the idea of the organizers was that the data shouldn't fit into memory, and you need to do queries into database. And people started doing very dirty hacks how to go around that. And it was no longer a competition about web servers, but how skillful the developer is. So, my solutions for those Highload Cups are still on GitHub. And sometimes I update the second one with the micro benchmarks. I didn't work too much at that competition. I had some more things to do, but while I was working on it, I developed some set maybe 10 or 12 micro benchmarks, like interpolation benchmarks or some collections benchmarks can still be useful, and I do update it from time to time. After that was my first big open source project called Pulsar.client, and it's still alive. And as far as I know, it is still faster than any other official libraries for Apache Pulsar. Actually, Apache Pulsar is a messaging platform similar to Kafka. Probably Kafka you would know better, but it has some unique, nice features compared to Kafka. And there are many different clients, but last time I measured, the .NET client was the fastest that allowed serving about 1 million messages per second. And I wrote an article about it last year on Medium. Actually, it was my first ever article on Medium. After that, I wrote some more articles, and it describes how I managed to do this kind of performance for this client. And fast forward to nowadays, now we meet the Oxpecker, and those who still unsure what it is, it's a collection of libraries. It's not just one library, it's a collection of 6. Many of them is Oxpecker itself. It's ASP.NET Core base framework, as Edgar said. It started as a fork of Giraffe with updates of some concepts, core concepts. For example, handler was updated, handler type, and also I got rid of some outdated functionality. And the main thing that I added was the second library is View Engine. It's my view on how HTML should look like in F#, and it was high performance from the beginning. And actually, Oxpecker depends on this library. Other libraries are OpenAPI library that allows generating OpenAPI spec from your Oxpecker API, and also HTMX library that is a set of helpers for HTMX. This is JavaScript library was in hype last year. Not sure about current year, but it allows developers some server-side application with the minimal amount of JavaScript. And those are 4 libraries, kind of server libraries. And somewhere about 4 months ago, there was a first release of client-side libraries like Oxpecker.solid, which is a DSL for Solid.js, which is very similar to what Oxpecker.viewEngine DSL is. And it's actually also a wrapper of its Solid.js APIs and allows writing front-end code that eventually generates JSX. And to generate JSX, you need the last library in this list is a Fable plugin, which is a compiler plugin that transforms this Oxpecker DSL into JSX that is used by solid.js library. Okay, let's go to today's topic, since I know people were interested mostly about performance. So when you think about performance, maybe the article from Stephen Tope comes up to your mind because he does it every year and writes about updates in .NET versions and performance improvement. But I'd like to take a higher view of performance, and I kind of come up with three types of performance that we should think about. And the first one is a real world performance. And I define it as number of operations that can be successfully handled by a product per chosen time period. And this is what's mostly interesting for business. An example of that, for example, how many login requests can be done by your website, or if you're hosting a game, what is your online, or in other words, how many game actions in a minute can be processed without latency degradation. And there are certain characteristics of this performance because real users can feel it. And usually there are many components in a system that are involved, which means that can be tweaked on different levels in many creative ways. Such performance is also unique for almost any business. So once you get from company to company, you'll see that that everyone have performance issues, but they're all the time kind of different. And to be able to deal with such issues, observability is a key, and I'm talking about logs and traces that help you analyzing the performance of your applications. And whenever you get some problems, you use some tools like memory dumps and CPU profiles, where you can download them from production servers locally and analyze. And one of the definitions of this performance that it's almost never a goal to have high performance. Performance should be just good enough for users, and for a business, so all the users will be happy. The second type of performance, micro benchmark performance, and that is mostly applicable to the article I talked about. It's about how fast is a particular small piece of code. And we talked about it when we think which method is more effective. For example, what is the best way to sort an array of 1 million float numbers? And it's interesting that if you even slightly change the requirement, let's say you don't have float numbers, but integer numbers, then the most effective method is different. Such micro benchmarks, they can be very precise and objective, can be useful when resolving some particular bottleneck, often used in interviews. Usually you just run it locally, but instead of running it, sometimes it can be replaced by just analyzing assembly code that is generated. And of course, you run them locally and observe what is the CPU and memory usage for different competitors. And for such kind of performance, the more the better, right? So better performance is always a goal. So you know which option is better for you in such micro benchmarks. And the last type of performance I see is a competition performance, and this is where high load cap and taking power go into, and it's about how to beat opponents without violating benchmark rules. And conceptually, it sits somewhere in the middle between real and benchmark performance. And the characteristic of that is that you usually do optimizing for benchmark, so you don't think much about how well structured or organized your code is, how easy it will be to support it. You just optimize for benchmark and go with it. So you use some dirty hacks, and it's generally useful in marketing, which means you either promote yourself or your company, your product, And the main goal of this performance is beating competitors. So rather than jumping into tech and power right away, let's have a general view about Oxpecker and its components. So TLDR is that it is a little bit faster than ASP.NET Core minimal APIs framework. Then it's somewhat faster than Razor, and I also wrote an article about that with some explanations. Solid wrapper is just as fast as SolidJS since it's just a wrapper, and the same about Oxpecker.htmx. So if you want the architecture view on what is and how fast is Oxpecker, so this slide is for you. But we should dig deeper and see what is the difference between Oxpecker and minimal APIs. And for that, we go back to architecture view of a standard ASP.NET Core request pipeline. When the request comes in, it goes into the Kestrel server, which constructs the HTTP request object and passes it to the pipeline of middlewares, where one middleware goes first and it passes to another middleware and so on until the terminal middleware. So usually routing middleware is one of the first, followed by some other middlewares like the authorization middlewares, caching middlewares, and different others. And the last middleware is called terminal middleware. And this is where Oxpecker sits, or maybe it's minimal API or any other terminal middleware. So if you look at this picture, you can feel that most of the performance is characteristic of the Kestrel itself, the server, and Oxpecker is actually just one of the middlewares on the end, just like minimal API. So let's have a look at the difference. Now it's C# code. For those who are in C#, you can be happy to see the C# code in this presentation. It's a very small application where ASP.NET Core application, which uses minimal APIs and has just two handlers. First handler just returns hello 1 for the path 1, and the second handler returns hello 2 for the path 2. And the only difference is the handler type. In first case, you see the handler type is delegate, and this is a minimal API way. So delegate actually is any lambda that can take arbitrary arguments and return arbitrary type. And this allows us, for example, to generate OpenAPI spec without describing anything, because runtime can see through the reflection of the type of this delegate. And the second option is the request delegate, which actually fixed parameters and response types. The request delegate takes HTTP context as an argument and returns the task. And both types can be used with your APIs, and first one is minimal API way, and second one Oxpecker way. So what's the difference is that the actual type that is used by middleware is this one, request delegate. So it means that this delegate has to be translated to request delegate at some point. And this is where the minor difference between minimal API and Oxpecker goes, because this translation has to be done. At the same time, while this is a little bit faster, we can't construct the OpenAPI spec from the request delegate. That's why when you use Oxpecker, there is a special library that with its API, you can specify what is the type of input and the type of the output, and that's how the OpenAPI spec will be generated. Okay, so now let's go to Tech and Power demo, because people came here for Tech and Power, right? So this is the main screen of Tech and Power. Maybe it's not the one that you got used to. but it's, let me even refresh this page. The screen of the latest benchmark results. What you can see here is all the different runs that were done recently. And here you can see the run that's the latest one when it started, elapsed time means, and yeah, it means it's still in progress, just been running for 11 hours. And those are all the previous results. So let's take one of those previous results. I think this is the third one, and talk a little bit about this benchmark and what it does. Actually, let's close it and do it again. Just hit that. Okay, so you can see that whenever you open the results, actually I opened the results from 10th of January, and it opened the Fortune tab. And I think it's not coincidence because the Fortunes is the main benchmark here, but I'll talk a little bit later about it. So let's go about those different tabs here. We have different test types, and I will go through all of them from simplest to most complex. So simplest is plain text, and there are all different web frameworks that implement this plain text benchmark. So let's do some filtering here. We can do the filtering and disable all the platforms except .NET. So let's then apply it, and it never works first time, so we need to refresh the page. Okay, and here is the results for all the .NET benchmarks that we have. So what is a plain text benchmark? In this benchmark, your web server just need to return one string hello world. It can be absolutely hard-coded in your application, and it just shows the speed of your web server without doing any fancy stuff. And there are even more tabs here. So first tab is the best bar chart. Why is it best? We'll see when looking at the second tab. So this is kind of the most useful tab overall here. It explains how this benchmark is run. So here is a description: plain text responses per second. And you see some numbers here. If you hold up the cursor above, you see that it's about concurrency, which means how many concurrent requests are done to your web server. And there are different stages of this benchmark. And the best one is the best results among all these profiles. And as you can see here, in most of the frameworks, the best results are not on the highest concurrency, but at 1000K concurrency or 4000K concurrency, which means that web servers, even the platform ASP.NET Core, they don't like too many requests. So about somewhere between 1K and 4K requests is somewhat optimal for these benchmarks. The next tab is latency, shows some average latency of your requests. And then overhead, where you can set up how well your framework looks against some another framework. For example, Oxpecker against platform framework. So that is a plain text. The second most simple is JSON serialization. And again, I need to refresh the page to get just .NET results. And again, let's jump to data table. And what you can see that concurrency is lowered here. It's no longer those 4K or 16K requests. It's just up to 512 requests. And you can see that actually in most frameworks, the best results are with this 512 concurrency. And what's interesting about this benchmark is that even though it's called JSON serialization, because what it does is just serializes one object at the runtime. This object, of course, can be singleton, and you need to do serialization at every request. That's a requirement. But what's interesting that if you replace the JSON serialization with just hard-coded string like that, for my test, the difference is about 5%, not that much. So think of JSON serialization is almost like plain text benchmark, because JSON serialization part is just 5% of those results. That's why if you take different JSON serializers, you will see approximately the same results in the final table here. And the third benchmark, which I think is the main benchmark here, the fortunes benchmark. And again, I need to refresh the page to see the results. And what it does is described here. In this benchmark, you need to do the query to the database, which contains 10 rows, and add one more row at runtime and sort them, and take the results and render them in HTML. And before I forgot, let me return back to the code and show I already covered the plain text and JSON framework. So let me show how they look in code. So here is the Oxpecker code, and this is a route for plain text. So what it does, it just take this hello world text and returns it like this. We write those, we convert them to bytes and return them in the response. This is a plain text framework. And as for JSON, we do also something very simple. We take the subject and then write, of course, content type and serialize it into responses. Very simple. In this case, rather than using STG, I use span.json serializer. That's a little bit faster, but doesn't make huge difference in this benchmark as explained. So as for fortunes, here what we do, we load the fortunes from database and put it into some resize array, which is .NET list, and then we render them. Also, we add one extra item, sort them with a custom comparer, and render the results. Okay, and for example, here is a markup how it looks with Oxpecker DSL. And okay, I'll talk about some hacks a little bit later. Let's go to our benchmarks. And let's go to another type. It's a single query benchmark. And it's kind of similar to fortunes, except that instead of rendering HTML, you just need to output the JSON object. And the idea of this object is randomly generated at runtime. So let me show you. Let me show you the code. So this is our DB single query. So just load single row randomly from the database, and then just serialized in JSON. And here I don't even use span.json and use the default STG that comes with Oxpecker. So next benchmark is multiple queries. By the way, single query, if you look at the data table, it uses the same numbers as for concurrency as fortunes, for example. So it goes from 16 to 512 concurrency. And in this case, the bigger concurrency, the better results. So when we go about multiple queries, things go a bit more interesting. Let me refresh the page again. So here, instead of returning just one row, we return multiple rows. And the concurrency is always 512. And the difference in rounds is that each request reads 1, 5, 10, up to 20 queries per request. And those queries has to be queried sequentially. And because of we have to do those 20 sequential queries on each request, for example, you see how the performance degrades between one query and 20 queries per request. So we start somewhere about 700K per second, and then we go down to 50K. So, and this happens to all other frameworks. And if we have a look at this first tab, which shows the best framework, we can see that it only shows the last tab with the 20 queries per request. So the framework which degrades the least is the winner here. And let's see the code for that. So we go to, and the count is passed inside the URL. So when we do multiple queries, we first parse the query itself to find out what is the count, and then we load multiple rows, and multiple rows is here. So in a loop, we just do read single row from the database and returning them back in JSON again. And the last one is data updates. And again, we see the numbers. Numbers are similar to multiple queries. So let's refresh this again. And if you look at the data table, again, we see how the performance degrades with more and more queries per request we give. And if you look at the code, it is similar to multiple queries, except that at the end, we do one more update. So we still read multiple rows, just like in previous case, but at the end, we generate some command that does update and execute that command at the end. Okay, and when looking at those tables, maybe I will show you one interesting thing, why it's useful to look at those tables. For example, the single query framework. If you look at those numbers, how the concurrency increases, you can also see that the amount of requests successfully processed also increases. For example, if we increase concurrency twice, here the performance increases twice, and again here and here. And there is some interesting thing happening here. From when we're going from 64 to 128, the performance doesn't increase linearly. So in many cases, it increases 3 times. Here also increases 3 times. Sometimes it increases 4 times, and sometimes even more. And in earlier versions of the benchmark, there was a linear increase in Oxpecker as well. So I had to really poke around and make it increase just like the others. So I still don't understand why this non-linear increase takes place, but if it does take place, then the results are better. So I managed to hack the connection string so it will perform just like the other frameworks, to be higher in the final list. And that's an example of optimizing for benchmark. Okay, so let's go back to the presentation, and I'll show you some hacks collection. So let's start from the .NET, and the best advice I have here to do good in benchmarks is that you need to reuse objects. And I'm talking about maybe singletons that you can reuse between requests, and also about some pools. You can use some object pools, string builder pools, memory pools. Anything that allows you to reuse objects really improves their performance. And it also allows you to avoid allocations, which I put on the second point here. And if you think avoid allocation means turning everything to structs, of course, it's not the case. In many cases, turning your objects to structs actually makes things worse. but sometimes it makes things better, and you need to extensively test if it makes better or not. Also, there are two environment modifications that I made. First one, I disabled dynamic adaptation mode. This is the mode that was introduced in .NET 8, and in .NET 9, it became enabled by default. So what it does, it actually manages the size of your heaps, managed heaps, and how the size of the heaps is dynamically adapted. And we don't want it into benchmark because it make your results worse. That's why we disable it. And probably in your production, you might want to keep it on. That's why I put a disclaimer here. Use those at your own risk and always test. Next one is we disable ready to run. It makes startup time much slower. But because we know it's a benchmark, because we know there is a warm-up phase there, we can disable it so that JIT will have more information to do its optimization, and it makes things faster, even though the initial startup is much longer. And one more thing, we disable hill climbing. It's some algorithm for figuring out what is the optimal number of threads, and disable it also helps the benchmark numbers. As for ASP.NET Core, there is not much to say. I did pretty standard thing like disable logging and using chunked responses. So if you're not sure what is chunked responses, the web server can choose whether to specify content lengths of your responses, or you might not want to specify. And if you specify the content lengths, it's easier for client to parse the response. If you don't do that, it's hard for client. But in benchmarks, we don't want to make it easier for client to do faster. We want server to be as fast as possible. That's why we use chunk responses. By default, Oxpecker, like Giraffe, when you write JSON, for example, or use the JSON helper, it doesn't use chunk responses, but you still have options to write JSON chunked and write JSON chunked to not write the response length. Then for benchmarks with URL parameters, I use route instead of routef. Routef is good in your business line applications because it makes your code safer. Whenever the URL parameter changes, the type changes, and you have to handle it to fix the compilation error. So it's safer, but it involves also reflection. That's why it's a bit slower. And that's why in benchmark, I use just route instead of routef. Also use some span JSON for serialization, although it didn't give much benefit, still maybe 1% or so. But you should know that it's especially used for struct because system text.json cannot serialize structs without allocations. It does really good job on serializing objects. It does it without allocation, but structs it can't serialize without allocations. So span JSON is more useful for this case. For fortunes, which is the benchmark with HTML, I used view engine since it's a quite fast view engine, and I also did pre-rendering parts of response. So let me show maybe that in the code. We go to fortunes and render fortunes. Then, yeah, so here I pre-render the top of the response, this one, and the end of the response. So I don't have to render them every time. Only what's in the middle of the table I render every time. And it also gives better performance, of course. And I also used custom object compare, but all the other frameworks do that as well. And now the big queries. So let me show you something. Okay, so this is a commit that really led the Oxpecker to the first play last year at the single query and multiple queries benchmarks. And what you can see just removes several parameters from connection string. So that connection string was actually copied from Microsoft implementation of the ASP.NET Core benchmarks. And many other frameworks, including mine, just believed Microsoft said they know what they're doing, that they put the best possible connection string ever. And then I found out that if we remove some of those parameters from connection string, the performance actually improves. And after I did that, some of them actually came to my PR and noticed that and said, oh, we should do this as well. And then they did it as well to the ASP.NET Core framework benchmarks. And then they returned back with their platform benchmark to the first position again. But that commit is kind of the secret sauce of Oxpecker being at the top of benchmarks. Other than that, I need to bring your attention to those settings, for example, max auto prepare. So query preparation is very important to any kind of applications. You either should set it to auto prepare or do the preparation yourself. I tried to do manual preparation for this benchmark, but it didn't give any improvements, so I just kept it on auto prepare. And nice thing about that is when you do manual query preparation, means just writing your code, prepare. You can't use that with multiplexing. And when you use them in connection string like that, both auto preparation and multiplexing work well together, which I used as well. And what I also did, I disabled multiplexing for all benchmarks except updates. It seems counterintuitive because multiplexing should increase performance. But when you measure it, you see that it makes things worse, except one updates benchmark. So currently in the code, you see I have two connection strings for different benchmarks. For all benchmarks except one, I use regular connection string, and for updates, I use this multiplexed connection string, this multiplexing parameter set to true. Also, instead of using Dapper, I used npgscale parameters. Actually, if you're using Dapper, you are good. When I changed Dapper to raw ADO.NET, there was not much difference. So you are good to go with Dapper as well. But I wanted to see how I can just use npgscale driver itself, and I used npgscale parameter, and it's generic. And when you pass, for example, integers there, it avoids boxing in that case. Also, I pre-generate queries for several benchmarks and reuse commands. And this go in line with the advice I gave earlier that you need to reuse the objects in your applications, and that give better performance. Okay, and let's have some small talk about Oxpecker view engines. It's the most unique thing in Oxpecker. It was written from scratch with the performance in mind. And those are features of this library. It has strongly typed markup with compared to other libraries that we have. The difference is that it only allows certain attributes. For example, for input, only certain attributes are allowed, and those are not allowed for general text like div. It can render to string, byte array, stream, and text writer. Has also area attribute support, and if you're using Rider IDE, you can benefit from CSS highlighting. If you write inline CSS, it will be highlighted. You can also define custom tags by inheritance from the tags defined in the library. And it also provides you automatic HTML encoding, which is for security to avoid some HTML injection attacks. And about performance features, why this view engine is quite fast, is because it has 0 allocations on render. And it does so because it has custom HTML encoders. So whenever you use some non-ASCII encoding, normally you just write HTML encode.encode from built-in ASP.NET Core functionality, but it will allocate strings. And recently, the custom HTML encoder was added, so it encodes everything without allocations. Also, when you're rendering, the Oxpecker will use string builder pools, and it first rendered to string builder, and only then it will be rendered to output, and string builders will be reused. When you are building your elements, it also has minimal allocation because it uses some custom queue and heavy inline usage from F-sharp DSL, from F-sharp C computation expression DSL. And if you wonder about the benchmarks, there is a link here to this repository where you can see how I compared Oxpecker like this to different rendering libraries out there and the tweaked version of Oxpecker. And what is tweaked version you can read in the article about Oxpecker view engine. Okay, so oops, go back to the slideshow. And here are the conclusions from my talk. First of all, you need to clearly understand what type of benchmark you're talking about, what are its goals and tools, and whether you depend on any other benchmark, you need to deeply understand them to be able to reason about those tools and the benchmark they participate in. Also, you shouldn't make any assumptions. Always measure. And the example with connection string is the good one, where you don't just believe someone did his job well, but you need to retest it and measure. And don't just believe numbers in the marketing slides. Always check what they talk about. And the third is that your skills, time spent, and iterative approach define 95% of the performance. Tools are also important, but they're secondary to your skills and time that you put into those benchmarks. And with that, I want to thank you for coming today. You can connect with me at different platforms. And here is my handle. And with that, I'm open to any questions about Oxpecker. Thank you.
Thank you very much, Vladimir. Really awesome topic. Yeah, I have been monitoring YouTube and I haven't seen any questions. So let's see, we have some questions here in the chat. So feel free to just unmute yourself and ask a question or write it in the chat, and we will get it to Vladimir. We have a question in the chat. Says that, have you done any benchmarks on Solid.js?
Actually, it was in my plans to do one of the benchmarks, but I haven't done it yet. But normally what you would expect is that since it just normal solid code, it behaves just like solid in benchmarks. So if you have a look at different benchmarks front end, Solid is somewhere in the top. So whenever you use Oxpecker.solid, you should expect one of the best performance among the front end frameworks just because of Solid.js.
Right. Yeah, makes sense. Yeah, so if you want to, if any of you either watching us on YouTube or in the Zoom call want to talk about something F# related or want to showcase your project, just feel free to go to our website, amplifyingextra.io, and then you can submit the session from us. And yeah, it's been a pleasure learning about Oxpecker, and yeah, we wish you the best, and we hope that Oxpecker gets more traction, and more people uses Oxpecker, because yeah, I think it's very cool, and I think it's a fresh air on the backend, I guess, libraries
Okay.
and all of that. So yeah, good stuff. Um, so yeah, if we don't have any other question, I'm going to stop the live stream. So thank you everyone for coming, and have a good weekend.